Hi, everybody. Thank you for coming to my talk. My name is John Kohler. I work for Nutanix, and I'm here today to talk about improving virtualization-based security on Windows on KVM, specifically a feature called HVCI. So I'm going to spend a few minutes just context setting because I'm sure not everybody knows what VBS is in Windows. VBS stands for virtualization-based security. I'll build out a few points here. And effectively what happens in Windows when you turn this on, it actually silently enables nested virtualization inside of the guest VM. And there's a handful of services that run inside of this on top of a transparent layer of Hyper-V or Microsoft Hypervisor, where what you would normally connect to for a virtual desktop or a Windows server is itself actually an L2 guest. And there's another L2 guest alongside of it that's kind of a enclave isn't the right word, but a secure mode, higher trust level that holds various secrets for things like Windows Credential Guard or kernel driver integrity and so on. And this runs alongside things like secure boot and virtual TPMs and so on. And going a little deeper and kind of highlighting this in green here, what we're going to talk about today is goes by three different names: Hypervisor-Protected code integrity, Hypervisor-Enforced code integrity, memory integrity, and it also used to go by a term called device guard. All of them mean the exact same thing, and that's a feature of VBS that enforces various allocation protections and other driver protections inside of Windows, which sound great, right? Let's not corrupt various bitmaps and make sure that drivers are doing the right thing in terms of how you're allocating memory and writing the memory and making it executable or not executable and so on. But there's this one little sentence in the feature description that is load bearing, which is, I'll read it aloud, ensures kernel memory pages are only made executable after passing integrity checks inside of the secure environment. And this sounds great. And you think that with all the malware and things out in the world, you'd want this enabled by default. Sounds like a great idea. Microsoft thinks it's a great idea, but it doesn't work on KVM by default, at least. So that's what we're going to get into. So a slight level down to look at what virtualization-based security is under the covers. If you just have a regular Windows guest on KVM, you would think it looks a little like this, where you've got a hardware layer, maybe using QEMU or another VMM, some firmware layer, a TPM layer, and a guest with drivers and so on. Pretty straightforward. There's a button inside of Windows that's pretty innocuous. It just says enable better device security, and there's a little warning there that says like, hey, if you want this to be more secure, click this button. You'd be an idiot not to check it. And of course, you check it and it asks you to reboot. But when you reboot, it looks the same, but when it comes back up, it is transparently enabled Hyper-V and put what you would normally connect to into its own L2 guest and what's called a separate virtual trust layer, like VTL0 or VTL1. The other one's VTL1 or 2, I can't remember. But either way, it gives you this other L2 guest that's doing these services for you, like Credential Guard, like the driver integrity signing stuff. And you're kind of none the wiser, which is great. The idea is that it is transparent and it just makes your system more secure and everybody's happy. But if you zoom in on this diagram, there's this little tiny arrow, which I'm sure those with a superhero vision in the back of the room can't see. So I'll kind of blow it up and say that this arrow in this Microsoft diagram is load bearing. They don't tell you it is, but it is. So if it sounds so good, like I said, it should just be on by default, right? Well, not really. So if you pay attention to the details, there's a setup log when Windows sysprep runs, when the system gets installed. It talks about some method that occurs in some DLL that, of course, is closed source. You have no idea what it's doing. But it'll go and say that compatibility checks have failed, and it gives you this hex code that links to a table that you can decode. And if you look into the details, they give you this table with 17 or 18 bits, I guess, indexed from 0, that tell you why this might not work. And if you rattle down the list here, I won't read every single one of them, but there's a handful that kind of jump out of might be problematic for KVM. By default, for example, a secure boot and IO-MMU aren't necessarily exposed from QEMU, so you have to configure those things. You have to make sure you have the right firmware set enabled, things like EDK2. But even upstream EDK2 doesn't necessarily have all the features and functionality to just plug this in and have it work by default. But the thing we're here to talk about today is a bit for Index 5 here, which is this is all Microsoft says about it. It's just MBEC GMET required. What the hell is that? So let's click into that. And yes, it is absolutely required. Now this is just for automatic enablement. If everything you had this all configured, it would be enabled. You'd never know it was there. That's the goal. But like with many things inside of an operating system, you can just turn it on. There exists a registry key for you to flag this. It might be done by your an enterprise security team through group policy, or there's a handful of other ways to do it. And if you do this, I guarantee you will know you've done it because it works like shit. And this there's this document, and I'll bring it up here in a second, that talks about this thing called restricted user mode. So again, all Microsoft says about it in any of their documentation, saying if you don't have certain offload features, you'll be placed into restricted user mode. And what happens is you end up context switching back and forth in between the lower VTL and the secure VTL a ridiculous amount. So we come back to our little arrow. That load-bearing arrow is this. So if you don't have MBEC or GMET, which the longhand form is mode-based execute control or guest mode execute trap on AMD, if you don't have those features exposed, you will run smack into this. And this is all the little Microsoft documentation says about it. It says, hey, if you've got a certain processor, you got to have these features. And if you don't, it might have an impact on performance. It doesn't tell you how much, right? So what actually happens? Now, this all came out of an escalation we had from a customer in Denmark who said, hey, we're moving over from another platform. Our entire fleet has secure boot and device guard and credential guard and every feature you could turn on under the sun enabled. It works really badly. So when we clicked in it, I said, okay, let's try to simplify this reproduction and just do something super basic. All I did was open up an Edge browser, run a YouTube video, and just have it play in a remote desktop session. And just having a basic video play produces 1.2 million VM exits per second. Like just running Internet Explorer is over 1 million context switches a second. It's really bad. Now, looking at it at a deeper level, we'll talk about the more detail-focused benchmark in a few slides. We used a benchmark facility from a company called Logging VSI, which is a great load runner. I'm sure I'm doing them a grave injustice by summarizing it like that. And you can see that just turning on this one registry key decreases user experience by an average of 2x. It also decreases the achievable density on insert latest and greatest here, Intel, Sapphire Rapids, Emerald Rapids, whatever, by about 2x as well. So your user experience from a single virtual machine goes down by 2x, and your ability to achieve density on a given host goes around by 2x as well. So you just run out of CPU. It's god awful. And you know, when I was making this presentation in another forum, our marketing team reviewed it. I used some other language in there that it said was insensitive. So I just summarized it to say it was just sluggish, is the marketing appropriate word for it. And really, for the larger KVM ecosystem, it just means we need to enable these hardware offloads. We'll talk about MBEC, so that's what I've been focused on. But know that like AMD's not getting out of this for free either. So the results with without guest mode execute trap are similar, and I can show those. So for the crowd, what is MBEC? Let's build this out here. So MBEC is a processor feature that effectively allows you to split the page table entries execute bit in two, right? And the idea is that for those memory page execution checks that the secure environment is doing, well, if you could just have the underlying page table entries be programmed to be user space executable or supervisor mode executable, kernel executable, whatever you want to call it, you could just look at that and then not have to do this heavy-handed checking from the Windows side. It's also worth saying that part of the challenge here is that it's my understanding that the only people in the world who actually use this feature from Intel and AMD are the chaps over at Microsoft. Unfortunately, they make a software that a lot of people use, so we kind of have to worry about it. That one device integrity checking feature is the only feature in Windows that actually makes use of this. So even though it's more obscure, it kind of gets exposed to a very much broader base of Windows 11 and Windows 2025 users, because it's a very front and center cornerstone to the endpoint security inside of that platform. Now, okay, well, that sounds cool. It's a processor feature, so where's it been, right? It's actually been there for a while, and Skylake and Kaby Lake is the client version of it. It's been there since 2017, but unfortunately, it's not completely transparent. It requires the operating system to understand it's there and respond to the changes in the page table entries and exit qualifications and things like that appropriately. So it's not completely transparent. It has to be programmed in there. Now, fortunately and unfortunately, the processor feature on both vendors from Intel and AMD does get some exercise, but unfortunately in closed source implementations only. ESX and Hyper-V both have support for this. So good for them. So what do you do, right? If you don't have any reference implementations and there's no other compelling use case, like a feature in Linux or another platform that wants to use it, you got to crack open the book, which is of course the SDM. Now, those who have delved into Intel features know this document is very big. And unfortunately, there is not like a section on mode-based execute control. For those in the back of the room, since the text is a little small here, if you search for mode-based execute control, Intel was nice enough to just use the same term everywhere, but it's scattered across 17 different pages in a 5,231 page PDF. Cool. And really the only kind of load-bearing part of those 5,000 pages is this table right here, which just says if you have this secondary execution control enabled, the way that you should understand the page table entry bits here is changed, right? So now bit 2 is for the kernel mode, supervisor mode stuff, and then bit 10 becomes this user mode executable flag. So in KVM, I put it at RFC. I'll build this out a little bit as well. And the actual mechanics are easy-ish, right? Exposing an additional secondary execution control, I guess bit 21 or 22, if I recall correctly, and then having the user space VMM program that in, having the various setup routines on KVM, program that in and pass it through appropriately, and then teach the exit handler for EPT exit violations and the MMU to understand this a little bit. Now, admittedly, I think Sean could attest I took the complete wrong approach, so I got to redo most of it, but it does work. It at least proves the theory that it's possible to make this workload not suck on top of KVM. Now, this is kind of spoiling the benchmark results a little bit, but I also added interoperability with enhanced BMCS on Intel, which is just to say that if you had a guest that was doing nested virtualization that did not use a device integrity, you'd still want enhanced BMCS enabled to allied VM read and VM writes, which we'll see here in a second. So let's build that out a little bit. So talk is about performance. What do we do? I realize that I'm running up on time here, so we'll just get to it. So these are from our internal Grafana-based dashboards that look at Login VSI benchmark. And this concept that Login VSI has is called an end user score, end user experience score. And the idea is that you run a bunch of Windows VMs, it runs a bunch of tasks, opening different applications, measuring latency, measuring CPU, and it aggregates all that stuff together and says, hey, based on all of these data points, do we think that users are going to have a good time with this or not? And when you run Windows 11, I think there's a 70 VMs per host on some Intel processor here, they're pretty good. Now, when you turn on just credential guard or just the basics of virtualization-based security, there's a little bit of overhead. You see the score goes from 8.7 to 8.6, but still kind of in this green range. Things are all right. When you turn on memory integrity, red is bad. It sucks. If you go to this basic YouTube benchmark and look at RDP, you can see here in the task manager that just playing this lovely 4K nature video of this vista in Denmark shows it goes to 100% CPU. That's not great. And if you look at the exit statistics in KVM, you've got 1.2 million just looking at this frame, literally nothing else. There's nothing else going on. It's exiting like its life depends on it. But if you look at the details here, you can see that most of the exits are VM read and VM write, right? Which we talked about. Enhanced VMCS can help elide those things. So the first thought that comes to mind is, well, you don't have enhanced VMCS enabled. Why don't you just turn that on, you idiot? Like, okay, cool. We did that. And it makes it a little better. You kind of see my red goes to yellow here. We're using 52% CPU, but this is kind of a fancy video. It's CPU intensive. We can see that just doing that has cut our overhead down by 5.2 times to 200,000 exits per second, but that's still a lot just to use remote desktop. It seems kind of excessive. And if we go back to the benchmark here, we can see that just turning on enhanced VMCS does make a tangible improvement to the end user experience that the automated test runners perceive. And it actually does feel better when you're just kind of clicking around. It doesn't feel like this click, wait. It actually feels better, and the benchmark agrees with that. So it's 55% better. However, we still have this huge gap of, well, if we didn't have enhanced VMCS, how do we kind of get this back to green? And what I didn't show here is when you benchmark this on other platforms that are not KVM, all the bars are green, right? So clearly we can do better. So with the RFC v1 code, doing the same URL here, this Denmark nature video, down to 41% CPU and roughly 50,000 exits. So we've cut the amount of exits here by 24 times, which is quite a bit. But exits or no exits, CPU or no CPU, really what matters is, will the customer complain? We love them, right? But we want them to have a good experience. Will they complain when they turn this on? And the answer is, I don't think so, because the overhead is like 1% now. So that little purple notes field that said, hey, there might be a big performance hit, this is what they were talking about. And when you turn on the MBEC, you effectively get all your performance back, which is nice. So what do we do from here? So for the second RFC, which is so we've got 1001 context, which is this year myself. So I'm hoping to get that out here in the back half of the year. I'm going to address some comments, add the KVM unit test coverage, and hopefully we can converge on that as a community and then and kind of get that out there. I will say I don't know what the conversations behind the scenes are at things like AWS Cloud or Google Cloud, but I believe both vendors say we don't support this. So hopefully having this in the upstream kernel will allow our cloud partners to use this as well. Now, let's not forget about AMD. Like I said, they don't come out unscathed here. Unfortunately, it's not one of these, well, it's just one ISA, you turn it on, it just kind of like goes. There is a thing that does that in AMD processors. Its implementation, of course, is different. So we've been going back and forth with Amit Shah and I to have a discussion on how we can kind of come together and maybe launch them at the same time, maybe launch them one after the other. But we at least want to, from our perspective, get the Intel side out first, because for us, that's a larger part of our fleet. But AMD, especially with the rollout of Genoa and Turin, have been kind of coming up from an adoption numbers perspective. So on the Nutanix's side, we want to solve both at the same time, but we're going to try to get the Intel stuff out first. So that's 20-something minutes here. Any questions? Comments, concerns, tomatoes, flames? I'll take them all. When it'll be sent when it's sent. You can thank, I won't name and shame other vendors who have taken all of the oxygen out of the room, unfortunately. So they're dusted now, so I'm hoping to get that out and rebase that on 6.16s and send that out, get that going. There's not a horrible amount of work, it's just needs to get done. And the question was, when am I sending it out? So I got to repeat it for the recording. Yeah. I will always take help. I don't want to be one of those like, I'm the only one who can do it. If someone in here says, hey, I know exactly how to do that, I'll send it out tomorrow. Like, I'll give you all the credit. I don't care. No, well, the only trouble I was running into was in the KVM unit test side. I was running into some issues with the way that the EPT tables are getting installed. It seemed like the code there like just didn't understand. Obviously, I had to teach it how to do different things, but it seemed like it didn't even work. I don't want to say this. It didn't. When I got it passing with MBEC, it wasn't passing normally. It was like that code needs a little rework just to. Like I think it only works the way it works, if that makes sense, and that it might not actually be doing what the SDM says it should do. So, but yeah, I can send out the. It only works with MBEC patch series just as a comment to see what I either did wrong or is there something wrong with the test that. Yeah, yeah, absolutely. So there's 3 parts to the KVM unit test series that I have internally. There's one is the there's a bunch of cleanups that I want to do in there because just from a mental load perspective, there's a bunch of stuff in the BMX code in the KVM unit test side that just like the variables are named differently and trying to track one to the other. So I'm like, fuck this. We gotta. In my opinion, you should have, if I'm searching for a keyword in the Linux code base and there's the exact same feature set in the KVM unit test code base, like they should be the same. I mean, I'm probably preaching to the choir, right? Yeah, well, I might just rage quit and do it. But no, I have a cleanup series that just kind of matches the two and fixes a few things there. So there's that part, which I can get out. It only works with MBEC part. And we also have the same series for the GMAT side for the basic test for those. So I can at least get those out. As at least, if nothing else, we could take the cleanup ones, knock on wood. That should be helpful for everybody who looks at that, who doesn't want to smash the keyboard when the variables and bits are named, have the same values, but name different things. So, but yeah, no, it's good encouragement. I want to get that done in the next month or so.
The Windows VBS, how do you see the most effects here around VSM and enablement?
Great question. Right. So I'm probably going to. So the question was basically, what's the deal with VSM and this feature and functionality? So VSM is kind of at a layer below this. So VSM, what that is virtual secure mode, which would make KVM be similar-ish to the way that Hyper-V manages things, where you have different virtual trust layers. I think Paolo called that planes, and having different domains inside of user space and then translate those into KVM, which then Windows could consume. Now, in theory, just having the non-nested version, which is just having the VSM framework, should make it perform a lot better since you wouldn't actually have these nested things. But I haven't tried that. Another one of my colleagues had set up the VSM proof of concept that the guys at Amazon had, and that does work pretty well. I don't think they're necessarily mutually exclusive, though. They should be able to layer on top. One of the things that we want to do is have a VSM-enabled KVM setup that we can then put MBEC on just to see how they play together. They should, but you know, we'll see. Haven't tried it yet.
Performance?
What's that?
In terms of performance, how much do you think you could get better?
With VSM?
With VSM at the hypervisor.
See, well, so from my perspective, I honestly don't care. And I'll say that in the most sugar-coated way possible. I don't care because as long as the benchmark is green, I don't really care how we achieve that. If it's with VSM, Excellent. If we have to use VSM and MBEC, great. Or if VSM comes later because it's predicated on planes, which will land whenever, we could do both, right? You know, honestly, I just would prefer something that, one, everybody agrees on, and two, just kind of works across both on-prem incantations of KVM-based platforms as well as cloud provider things. Because the things we wouldn't want is to only use something bespoke in our product that all of a sudden every other incantation doesn't use, and then we end up being the black sheep. So if VSM ends up becoming the true north, I'm happy to throw all that away if the benchmark came back at the you know, same level. I think in general, though, even with this, nested virtualization isn't free. So if we can get rid of nested virtualization, cool. That's great. You know, again, fingers crossed, it should be better. That's at least what Microsoft says. And the early indications from the you know, the kind of proof of concept work from the VSM look good. So cool. Yeah. So good questions. Any others? I know I think we're running out of time. I'm happy to take them either now or in the hallway afterwards. Cool beans. Well, the only other thing I'll throw up here, like I said, the AMD isn't leaving unscathed. Not to throw them under the bus, but it's not red, but it's orange. Turn on memory integrity, and it's a bit of a ding here too. So hopefully when we get the GMET side up, we'll see that go green again as well, and everybody can be happy about that. All right, thanks for coming to my talk. I appreciate it.